In this video, I'm going to demonstrate how to analyze hole measurements. Most parts contain holes. The typical manufacturing process involves a tool machining multiple holes. For example, the mounting surface of a transmission case has many holes machined with one tool. To evaluate this type of manufacturing process, you need to group the holes together and evaluate them as a pattern. I'm going to show you how part measurement data is collected, analyzed, and the optimal hole pattern adjustments calculated. To start this demonstration, I'm going to simulate measuring 6 holes. I'm going to use the RPM training simulator application to simulate measuring a part. To collect the measurements, I'm going to use QC-CALC Real-Time. QC-CALC Real-Time provides statistics. It will tell you when a process needs attention. The Reaction Plan Manager++ application, which is here, it will take the data from QC-CALC Real-Time, analyze it, and it'll tell the operator how to react when attention is required. Ideally, this application will tell the operator exactly how to adjust his machine to fix whatever the process problem is. Let's start by measuring a part using the training simulator and see what happens. I'm going to click on the Inspect button here. By clicking on the Inspect button, it's as if I actually measured a part on a CMM. So I'll click on that button. You'll notice that QC-CALC Real-Time, it grabbed the data, opened up the appropriate database, and added the data to that database. It then transferred the data over to Reaction Plan Manager for analysis. Reaction Plan Manager did an analysis, and you can see here it's giving us instructions that there are no rule violations, which means there is no reaction required when it did the analysis. All the dimensional items are green inside QC-CALC, so everything looks good. So there's nothing really to do at this time. You will notice inside Reaction Plan Manager++, there's Machine A, Machine B, and Machine C. The software gives you the ability to group or filter the data using different criteria. In this example, we're grouping the data or filtering the data by machine. You can do the same type of filtering and grouping inside QC-CALC Real-Time as well. You'll also notice there's a bolt pattern analysis button here. If I click on this button, it will launch the bolt pattern analysis, and then we can actually look at the holes. I'm not going to do that at this time. I'm going to wait and actually measure some more parts so we can get some more variation in the data. Okay, so I'm going to check the shift data in the training simulator, and then I'm going to go ahead and inspect a part. Now what that will do is that'll add variation in the data so we can actually see more than just data bouncing around the nominal. So if I keep on clicking Inspect, eventually you will start seeing the data shift. And keep going. That's just a diameter. Yep. So you can see that in this case, Reaction Plan Manager identified some instructions. So I can tell the operator would follow these instructions to actually react to the data. This was a percent of tolerance rule violation. Let's go ahead and measure some more parts so we can see more variation in the data. Okay. So here you can see inside QC-CALC we've got all kinds of yellow and we've got one dimensional item that's red. So we've got some issues here that need to be resolved. Let's go ahead and measure a couple more parts. Okay. If I try to figure out how to make adjustments using data from QC-CALC, it would be difficult. I see I've got a lot of issues, a lot of dimensions that need attention, but I can't visually see how it all relates, nor can I come up with the appropriate adjustment values. With Reaction Plan Manager, I have a little bit more information. I can see that I've got two true position holes that are out and need attention, but again, I really can't tell what to do with this. I need to look at all the holes at the same time. This is why you need the bolt pattern analysis software. If I click on this button, it will pull up the bolt pattern analysis software, and I can visually see what's going on with my process. Here I've got machine A, machine B, and machine C. So machine C is the one I've got issues with. And now I can make more sense of it because I can actually see a plot of where the hole locations actually fell. So how do we interpret this information? Here we have a plot. This plot shows us the 6 holes. Now each one of these crosshairs here, you see there's a crosshair, represents the nominal target. The inside circle here represents the true position tolerance zone scaled up, so you can visually see it. You'll notice there's a second ring around the true position tolerancing zone. That second ring represents the maximum material condition. If you include the diameter information with the analysis, it will calculate the minimum maximum material condition. So it'll buy you a little bit more tolerancing if that's a requirement on your print. The green dots and yellow dots represent parts. Now visually you can see that the pattern has shifted slightly to the right and kind of rotated. So you got a shift and a rotation with regards to the variation of the data. The empty box and the filled box here graphically shows you the shift in the data. This error values over here are the actual calculated values. So you can see my pattern has an error of 0.00215 in X, 0.00198 in Y, and a rotational error of 0.03234. The software has best fit tools, so I can simulate what will happen if I corrected for the error. If I click on the Control tab and then click on the Best Fit button, it will do the best fit simulation. So I can visually see what will happen if I correct for those errors. And here in the correction box, these are the values that the operator would use to fix his manufacturing process. What's significant about this application is that it looks at more than one part. It looks at a stream of parts. So the results that you get are going to be optimal. There are other features in the software that are quite useful. For example, if I click on the Data tab here, it will not only give me some graphical information, but it will also give me numeric information as well. If I can expand on this and click on this selection here, and I can expand the feature info, and I can bounce from one hole to the next hole and isolate just that one feature so I can see what's going on. If you want, you can also look at each individual part. In this example, we're only using 4 parts, but I can bounce back and forth from one part to the next part by just selecting the appropriate one. Let's shut down the bolt pattern analysis software and measure some more parts so you can see how all the pieces fit together more clearly. I'm not going to save this project. In this example, instead of sending the data to machine C, I'm going to send the data to machine A. So if I inspect, you can see there's no rule violations for machine A. I'll go ahead and inspect some more parts. And the data should start to shift. Okay. There we go. You're probably wondering why QC-CALC reacted more quickly than Reaction Plan Manager++. Reaction Plan Manager, this particular solution in Reaction Plan Manager++ is looking at the last 4 parts and averaging it out. The idea behind it is it moves a little slower so that an operator is not overcompensating or overreacting to it. So let's go ahead and do a bolt pattern analysis and let's see what the results yield us. So here we can see machine A. We have a similar type of variation, different values for our error. It's still shifted to the right and shifted up a little bit, and it's got a twist to it. And we can go ahead and do our best fits. We can look at machine B, and machine C is still, we haven't made any changes to machine C. So you get the idea. With the click of a button, we pulled up the bolt pattern analysis, and we were able to pull in the data from Reaction Plan Manager and figure out exactly how to adjust our manufacturing process. In this video, I showed you how to analyze hole patterns using QC-CALC Real-Time, Reaction Plan Manager++, and the bolt pattern analysis software packages. To learn more about these software solutions, visit www.beckerqualitysolutions.com.